As to solve, sine 2x minus 60 is minus 0.5. So what we're going to do is find all of our values for 2x minus 60 and then add 60 and divide by 2. The only thing we've got to be careful about is the range of values. So what we can do is change the range for the 2x minus 60. So if I times through by 2, I'll get 0 to 720. And if I minus 60, it will be minus 60 to 660. That's the range I'm interested in. So 2x minus 60, I just need to do inverse sine of minus a half, which is minus 30. That's in my range. So we're okay, because although it's negative, I'll be adding 60 to it in a minute and then dividing by 2. It'll give a value of x in the range. Let's find some more values. So I'm going to do a little sketch of my sine graph just between 0 and 360, but I will include a negative part as well. So I'm interested in where we get 0.5. And so I've actually found that value there. And so to get this one here, it's actually going to be, see, this distance is the same as this distance. It's going to be 180 plus 30, so 210. Or you can do 180 minus x. 180 minus minus 30 also gives 210. And then to get this one, I can just add 360 on. Use that property, I'm going to get 330. And once I've got these two, I can just keep adding on 360 to each of them until I'm outside the range. So 360 plus 210 will give 570, still in the range. 360 plus 330 will give 690. Okay, I'm going to reject that one and anything beyond it. I can also see that anything to the left is going to be, like I'd be minusing 360, it's going to go beyond the minus 60. So those are going to be my 4 solutions. If you're using cast, they're not actually my solutions yet, and you still need a little bit to do just to add, but they're my solutions to 2x minus 60. So if you're using cast diagrams, so we've got all sausages turn cold. We've got a minus angle, or it was a minus sign. So we're here at the moment, 30 degrees, and we also want to be here. So we've got our minus 30, absolutely fine. And then to get the next one, we would go all the way around here. Wait, sorry, that's not right. Around here, sorry. 180 plus 30 gives us our 210. And then to get the next one, we just keep going. Actually, it's going to be 360 minus 30. And then you just keep adding on 360 in the same sort of way. 570 being our other one. So that's a way of explaining it using cast diagrams. Sometimes people do it slightly differently, but that does get us the same answers. Hopefully you're happy with that. So I'm going to now, I'm going to go straight for actually, add 60 to each and then divide by 2. So I'll get 15. Then I'll get 270 over 2, which is 135. Then 630, giving 315 degrees. And sorry, that should have been minus 50. No, it shouldn't have. That was absolutely fine. Oh, I just missed I actually missed the 391. So 390 divided by 2 would be 195, and it was 315. For this sort of question, if it seems like it's, you're the sort of person who might make mistakes, and actually, to be honest, I am, what you could do right at the end is just sub your answers back in. So we've got sine of 2x minus 60. So I can just pick a couple maybe, or I could do all of them if I had time. So sine times 195 minus 60, we're looking to get minus a half, and it checks out. It doesn't take too long to just edit this then to say 315 and the other two as well. Okay, good. In part B, we're asked to show that this is true. Now, this means identity. We're trying to show a trig identity. So I'm going to start from the left-hand side and try to get the right-hand side. Just write what we've got, tan x cos x over 1 minus cos squared all to the half. Okay, and I'm trying to get 1. So first up, I could write down that tan x is actually equal to, or technically identical to sine x over cos x. And I'm going to replace tan x by that in a minute. And then sine squared x plus cos squared x is identical to 1. So these are the two to remember. They're both going to be used here. Because what we're going to then get is sine x over cos x when I replace tan x times by cos x all over, and 1 minus cos squared x is actually sine squared x. And then to the power of a half is actually a root. The cos x, they cancel, so I'm left with sine x, and the root sine squared x is sine x, and we're there. Those two will cancel to give 1, which is the right-hand side. Just going to say, actually, I didn't say, did it say prove? Show that. Just say as required. So yeah, start from one side, use trig identities to get the other. This is true for any value of x.